Thank you for joining me today. I'm going to be talking to you about evaluating algebraic expressions. All right, and first of all, let's just remind you of a few terms that you've probably heard or that you will hear throughout this tutorial. First of all, what it means to evaluate. Evaluating means to find the numeric solution. Okay, you can simplify in math or you can evaluate. Simplify a lot of times means get it down as far as you can to its smallest result. In some cases, variables will still be involved. But to evaluate means they want a numeric answer. Then you also have what is called a coefficient. A coefficient is simply a number in front of a variable, okay, like this 3 and this -2 that you see here in the example. Then, of course, what is a variable? Well, a variable is simply a letter that takes the place of a number, okay, and that can be in any expression or an equation. And then the order of operations. The order of operations is the order of math operations that you need to take in order to completely and successfully finish a math problem, usually an expression. Equations, you kind of use the opposite of the order of operations. So we use order of operations when evaluating expressions. All right, so let's take a look at some examples here of evaluating. You can see we have the expression 56 divided by 7 plus 3x. Well, they want us to evaluate when x equals 5. Okay, so what that means is we need to take that value 5 and substitute it into our expression and then solve. But when you do that, you have to keep in mind that this is 3 times x right there. It's not just going to become 35 when you substitute the number in. So I'm going to rewrite it as 56 divided by 7 plus 3 times 5. Now notice I'm including parentheses when I do that. And I like to do that because it separates what was originally there from what I've substituted in. And in this case, I'm going to go ahead and do that first. In actuality, you should really just do division to multiplication first. So using order of operations, we know that we cannot add 7 plus 3 yet. So actually, the first thing I'm going to do is 56 divided by 7, because when you do multiplication and division in these types of problems, you simply do them left to right. So 56 divided by 7 is 8. All right. Then we're going to say plus 3 times 5. So I'm going to go ahead and do that multiplication now, and that's going to be 8 plus 15. 5 times 3 is 15, and you can see then to finish off this problem, you're just going to add 8 plus 15, which will give you a solution of 23. Now you can kind of see showing all my steps here, and that's a very important thing to do, and I'm sure your teacher probably tells you that quite often. The reason why we want to see all those steps one after the other is because if a mistake is made, it just makes it a lot easier to go back and figure out where the mistake was made and then how to correct it. All right, let's take a look at another one here. See here we have 45x minus 2y plus 15. This time we're going to be incorporating some fractions, okay? And we're going to have two variables to substitute in for. So I'm going to rewrite the problem, substituting in those values. And again, 45x means 45 times x. So when I substitute 1/5, I'm going to do so with parentheses. All right. Then minus 2y, 2 times y. So that's going to be 2 times 3. Put the 3 in parentheses. All right. So now you can clearly see what has been placed into the problem from what they asked us to do. And now we've got to do a little bit of fraction math. So off to the side, you might want to do some scratch math. 45 over 1 times 1/5. Right? When you do multiplication of fractions, you multiply straight across the numerator, straight across the denominator. So we're going to end up with 45 over 5, which means 45 divided by 5. 45 divided by 5 is 9. Right? So that part of the problem becomes 9. Right. We can keep moving left to right here. We have to do this multiplication first because that does come before the addition and subtraction. So 2 times 3 is going to give me 6. And then we can just bring down the plus 15 part. Now again, according to order of operations, addition and subtraction, when that's all that's left in the problem like we have here, you just move left to right. So we'll do 9 minus 6, which is 3. And then 3 plus 15 is going to give us our final answer of 18. So again, you can kind of see you get this, what is called an expression funnel, all the way down to your solution. All right, so let's take a look at another example here. This time we're going to be substituting in 2 for x and 4 for y. So I'm going to go ahead and rewrite my problem, substituting in those values. That's going to be 27 times x is 2, so put that in parentheses, divided by 2, minus 3 times 4, which 4 again is what you're substituting in, so notice I put it in parentheses, and then plus 16. All right, so again, now analyze the problem and make sure you're doing the order of operations. I see some grouping symbols, but again, those are a part of multiplication. So whatever comes first, all I see is multiplication, subtraction, addition, and division. So since it's multiplication and division, I just do left to right. So 27 times 2 will be our first step, and if you don't know what that is, off to the side, do a little scratch math, be sure. And you see that you get 54 divided by 2. I'm just going to bring everything else down that I haven't used yet. Do things step by step here. So now I'm going to do 54 divided by 2 because that's the next piece. That's going to end up taking me right back where I started. 54 divided by 2 takes us back to 27. Now I can continue here, minus 3 times 4, which is going to be 12, and then plus 16. You can see we're just working our way down. 27 minus 12 plus 16 is just a subtraction and addition, so that we can go ahead and just move left to right. 27 minus 12, 7 minus 2 is 5, 2 minus 1 is 1. And then 15 plus 16, again off to the side. There's nothing wrong if you don't know it in your head. So go ahead and work that out. And you can see that your final solution then becomes 31 all the way down. Lots of steps there, I know, but again, your teacher will be happy to see that step by step because they'll be able to pick out any mistakes and correct them. All right. So how will this be incorporated into word problems or different contexts? Well, here's an example. If I need to plant new grass over the soccer field is diagrammed below. You can see that it's 45 yards wide and 100 yards long. So they're wondering how many square yards of seed I will need. So on the next page, we'll work our way through this example here. You have my field. What this actually becomes is an area problem, because when you're covering something, you're covering it by a specific area, in this case square yards. So what that means is we're going to have to use the area formula. If you've forgotten what that is, that becomes area equals, for a rectangle, length times width. Okay, and our width, as I mentioned before, was 45, and our length is 100. Alright, so just as before, we can take our values and substitute them into our formula. So area is going to equal 100 length times 45 width. And of course, then we'll need to solve that. So area is going to equal 100 times 45. So off to the side here, we'll work that out. 5 times 0 is 0, times 0 is 0, 5 times 1 is 5. Hold the place with a 0, and then you go and do your zeros and your 4. And you see that you end up with 4,500 square yards squared of seed. All right, so let's look at one more like that, but in this case, we're going to actually use a different shape. This time a triangular hole's been cut out of a piece of wood, and you can see the dimensions there. And this time they're also wanting to know what the area of that triangle would be. So again, I'll help you out here and give you the formula if you've forgotten what that is. The formula for the area of a triangle is area equals base times height divided by 2. Or in some cases, you may also see it as 1/2 times base times height. Either of those mean the same thing. It's just really depending on how your teacher taught it to you. I'll show you both. So in this case, what you have to do when you look at this triangle is determine what the base and height are. You'll notice that we have 3 dimensions that they've given us. Okay, that can be a bit confusing. Well, I'll try to make this as simple as possible for you. And I will tell you that when you're dealing with a right triangle like this, and the reason why we know it's a right triangle is because of that symbol right there, the base and the height are the 2 sides, what we call legs. They're the 2 sides that make up the 90-degree angle. So this other value of 32 is not really a part of the problem at all. So the base and height of a 90-degree triangle are always the sides that make up the 90-degree angle, every time. Okay? So for this problem, our base is going to be 20. Our height is going to be 25. And just as we've been doing, we're going to take those values and substitute them in. So let's use the top formula here. We're going to do area equals base times height, so that's going to be 20 times 25, all divided by 2. Okay, so off to the side we need to figure out what 25 times 20 is. And that's going to be, alright, after we get through those first zeros, 2 times 5 is 10, carry the 1, 2 times 2 is 4, plus 1 is 5. Looks like that's going to be 500. So area here is going to be equal to 500 divided by 2. So off to the side, if you don't know what that is, we got to do a little bit more scratch here. 2 goes into 5 2 times. 1 left over, bring down your 0. 2 goes into 10 5 times. Alright, and you can see then that we do end up with 250. Okay, whoops. There it goes. 250 there. So our area is going to end up being 250 centimeters squared. Alright, this has been a quick tutorial on algebraic expressions. Thank you for joining me.